last video we did compressional beam thickness testing. Alright, this time we're going to do compressional beam thickness testing, but we're going to do it with a dual element transducer. So here's the dual element transducer I picked. It is a Panametrics DHC 711 RM. That doesn't make any difference, that's just serial number stuff. It's a 5 megahertz, quarter-inch diameter. Let's get it up here close enough so we can be right in your face. Like I said, 5 megahertz, quarter-inch diameter. Here we've got the two elements. We've got one element over here, another element over here with a crosstalk barrier in between. And that's going to keep those guys from talking back and forth to one another. So what we want to do is look at the difference between plain old compressional beam and then dual element. So last video was plain old compressional beam, okay, single element stuff. Now we're going to switch over to dual element compression. Okay, so you saw what was going on here. Okay, looked like we had a weird looking signal right there. Okay, which that's going to be the end. Okay, if I just touch the end of this, you see how that's dampening. Okay, so you know that that transducer is working. Okay, same kind of thing over here. We know that's the end of our transducer. So we're touching the end of it there. So if I just plunk this down without doing anything else, let's just see what happens just for fun. Okay, I'm just putting this on my 1-inch block here. Let you look down here real quick. Okay, here I am, I'm just on my 1-inch block. So I'm doing that. Okay, that's off the block. There's the transducer. Now it's on the block. Alright? So we need to see what kind of difference that makes. Okay, off, on. Alright, so now we know that we have a dual element transducer, but we haven't changed any of the settings to actually tell the scope that we have a dual element transducer. So let's do that. Go to pulsar. Okay, damping's low, power's low, dual is off. We need to turn that on. Okay, and you see what it did there. It changed our signals quite rapidly. But now the problem is we can't see our 1-inch signal. Alright, the reason we can't see our 1-inch signal is because this, just bumped into you there, acts as a delay line. Okay, the transducers themselves, the little elements, are actually back here, and then it's a delay face all the way from here down to there. So what we're going to have to do is take our delay out. What do we got going on here? Looks like I got a bad cable. Huh, sure enough, I do. Alright, so let's just see what happens. Let's go back to our base menu, go back to our probe delay. Okay, probe delay is just telling me it's not a good deal. There he is, just barely. That just looks really bad. Now it looks good. Okay, so now with the dual element, this signal may not be the prettiest, but it's going to work alright for telling us thickness. Okay? So we've stretched this out. Let's get a whole view here. See if we can see. There's 1/4 inch, okay, 1/2 inch, 3/4 inch, 1 inch. That's what I'm going to do. So there's our 1-inch signal. Okay, we know we're not in the right spot. We're on a 1-inch range. So let's just take this thing, drag our delay back over here. Right there, there's 1 inch. There's 3/4 of an inch, which we're not necessarily right on. We're pretty close. And then there's 25, 50, 75, 100. So you see here, it looks like we've got 275, okay, which is fine. But if we take this gate and bring our threshold of our gate down, you see that number gets smaller and smaller very quickly. Okay, there we just moved it and we've drug it down to 260, but if we bring that gain up, there it is right there at 250. So that's one thing to be very aware of, is where your gate actually is. Okay, there's 758. There's 1 inch basically with 8 thousandths on the end. So we'll call that good. And the difference is, before with compressional beam we had our initial pulse right here, whereas now we've taken our delay way out there. And if we drag this thing back to where this is at 0, okay, there's our ½ inch signal, and there is a ¼ inch signal. Alright, so now if we keep pushing this out, there's a quarter. Let's line them up here a little bit. There's a half. There's 3/4 like we had before, and there's 1 inch. Okay? So quite simple, dual element there. So now let's switch that over to a delay line, which is going to be the same type of thing. Just keep it all in one video here, no problem. So here's our delay line transducer. Okay, I'm going to take this apart. We looked at this a little bit before. I'm going to put a little cup in between those contact face right there and the delay line face. So put a little coupling on there. Put that on there. Make sure we get the air out of there. Put it back together here. Now, before we ever go back, okay, we have dual on, and this is just a single element. So we're going to turn dual off. Okay, and you saw the little light go out over here. Dual on, dual off, and you heard a little click. So let's go back to our single element cable. Okay, here we go. You can tell something's happening. So now we're hooked up. Let's take our base menu, take our probe delay all the way back to 0. Okay, still on steel, still 1 inch range. If we go here on our 1 inch signal, our 1 inch step block, we got nothing. Now that's because our delay is slowing that sound down right here. Okay, so since that's slowing that sound down, that means that 1 inch signal is actually going to be out here somewhere. Okay, out over here somewhere. So we need to find it. So we're just going to take our probe delay, start pushing it over, go to our 1 inch signal here. That might be it. Okay, we're not sure of that, so we need to make sure that that's it. Okay, so I'm going different sizes on my step block here, and I'm not seeing any change. So that means I don't think that's it. I think that's something else. Okay, bring the gain down a little bit. Let me touch the end of this delay line. Okay, I'm touching the end of that delay line. That sound is dampening. So that means that's the end of that delay line. So now this signal is going to be our initial pulse. So we're going to take this delay and continue to push that over to use that as our initial pulse. So we're going to park it over there. Okay, and if we just keep going, I don't have anything on here. You see all these repeat signals. There's a repeat. I'm just going backwards now. There's a repeat. There's the first signal. Let's drag it all the way back to 0 though, so you feel more comfortable. 0. First signal. That's going to be our new initial pulse. Oops, went a little too far. There he is. Slap it on an inch. Ah, we got something happening. Let's give it a little more gain. Okay, let's go to 3/4 of an inch. Yep. ½ inch. Yep. ¼ inch. Much better. And you notice that these signals are much cleaner. That's because we've burned up a lot of the near field effect in the end of that delay line. So let's push that 1 inch signal over to where he's right on 1 inch. Okay, yeah, we're pretty close. We're 998. That's livable. 3/4 of an inch, right on. ½ an inch, right on. 1/4 of an inch, pretty much right on. If I'm within 5 thousandths, that's not bad. So 1/4 of an inch, half, 3/4, 1 inch. Okay, go over here to a different 1 inch piece. piece of steel. Okay, here's my new 1-inch piece of steel, and you can see that it's telling me direct readout. There's my 100% line for 1 inch. We're in pretty good shape. So not too bad there. And that's the difference between dual element and single element with a delay line. So if we go back to our pulsar and just look at that dual element one more time, okay, something completely different happened, or we lost our signal because we only have a single element transducer. And the single element's trying to talk to the second element, which is not there, so you can't get anything through it. So anyway, turn that off. Dual element right there. Okay, if we hit the end of this, you see this signal right here dampen down, and that's a good thing. That means we're right at the edge. Then we're 1 inch, 3/4, half, 1/4 of an inch. Just like that, easy money. Questions, comments, concerns, again, just feel free to get in touch with me. Have a good week.